Square of a number. When a number a is multiplied by itself, that is, it is raised to the exponent 2, or you can say raised to the power 2, or if a number has index 2, we say it is a square of a. That is, a into a is equal to a square. For example, 2 into 2 is equal to 2 square, which is equal to 4. So, 4 is a square of 2. 3 into 3 is equal to 3 square, which is equal to 9. So 9 is the square of 3. Similarly, 1 into 1 is equal to 1 square, which is equal to 1. 4 into 4 is equal to 4 square, which is equal to 16. Perfect square. We have seen above that 1 is the square of 1, 4 is the square of 2, 9 is the square of 3, 16 is the square of 4. Such natural numbers which are squares of the other natural numbers are called perfect squares. 1 is equal to 1 square, which is equal to 1 into 1. 4 is equal to 2 square, which is equal to 2 into 2. 9 is equal to 3 square, which is equal to 3 into 3. 16 is equal to 4 square, which is equal to 4 into 4. We have also learnt about square numbers in our junior classes. We have seen that square numbers can be shown by plotting dots in the form of a square. For example, 1 square is equal to 1, which is equal to 1 dot. 2 square is equal to 4, which is equal to 4 dot. 3 square is equal to 9, which is equal to 9 dot. 4 square is equal to 16, which is equal to 16 dot. Method to find or check whether the given number is a perfect square or not. To find whether the given number is a perfect square or not, we follow the following steps. Step 1. Write the number. Step 2. Obtain its prime factors. Step 3. Make pairs of identical prime factors. Step 4. Check if all the prime factors form pairs of identical factors or not. Step 5. If all the prime factors occur in pairs of like factors, then we say that the number is a perfect square. Step 6. If any factor is left and does not form a pair with the same number, then we say that the given number is not a perfect square. Example 1. Which of the following are perfect squares? A. 16, B. 54. Solution. A. 16 is equal to, dividing 16 by 2 we get 8. Dividing 8 by 2 we get 4. Dividing 4 by 2 we get 2. Dividing 2 by 2 we get 1. Prime factors of 16 are is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2, which is equal to, in the brackets, 2 multiplied by 2 multiplied by, in the brackets, 2 multiplied by 2. Prime factors occur in pairs of like factors. So, 16 is a perfect square. B. 54 is equal to, dividing 54 by 3 we get 18. On dividing 18 by 2 we get 9. On dividing 9 by 3 we get 3. On dividing 3 by 3 we get 1. Prime factors of 54 are is equal to 2 into 3 into 3 into 3, which is equal to 2 into, in the brackets, 3 multiplied by 3 into 3. We observe here that there are 3 3's. 2 form a pair, but 1 is left. 2 also does not have a like factor to form a pair with. Thus, 54 is not a perfect square. Example 2. Is 256 a perfect square? If so, find the number whose square is 256. Solution. Prime factorizing 256, we get, here dividing 256 by 2, we get 128. Dividing 128 by 2, we get 64. Dividing 64 by 2, we get 32. Dividing 32 by 2, we get 16. Dividing 16 by 2, we get 8. Dividing 8 by 2, we get 4. Dividing 4 by 2, we get 2. 256 is equal to 2 into 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 2. Grouping the factors in pairs in such a way that the two factors are identical, we get 256 is equal to bracket 2 multiplied by 2 into bracket 2 multiplied by 2 into bracket 2 multiplied by 2 into bracket 2 multiplied by 2. We can see that after grouping them into pairs of like factors, no factor is left unpaired. That means 256 is equal to 4 into 4 into 4 into 4. Grouping again, we have 256 is equal to bracket 4 multiplied by 4 into bracket 4 multiplied by 4, which is equal to 16 into 16, which is equal to 16 square. So 256 is the square of 16. Patterns and squares. Sometimes squares of numbers can be obtained by observing patterns. For example, 1 square is equal to 1. 11 square is equal to 121. 111 square is equal to 12,321. 1,111 square is equal to 12,34,321. 11,111 square is equal to 12 crores 34 lakhs 54,321. 5 square is equal to 0 into 1 into 100 plus 5 square, which is equal to 25. 15 square is equal to 1 into 2 into 100 plus 5 square, which is equal to 225. 25 square, which is equal to 2 into 3 into 100 plus 5 square is equal to 625. 35 square is equal to 3 into 4 into 100 plus 5 square is equal to 1225. 45 square is equal to 4 into 5 into 100 plus 5 square is equal to 2025. 55 square is equal to 5 into 6 into 100 plus 5 square is equal to 3025. Example 1. Using properties of perfect squares, which of the following are not perfect squares? A. 19, B. 36, C. 63. Solution. A. 19 is neither a multiple of 3 nor of 4. Also, 19 minus 1 is equal to 18 is not multiple of 4 or 3. So, 19 can never be a perfect square. B. 36 is divisible by 3 and 4 both, as well as 36 minus 1 is equal to 35, which is divisible by 5. So, 36 may be a perfect square. C. 63 is divisible by 3 but not by 4. But 63 minus 1 is equal to 62 is neither divisible by 4 nor by 3. So, 63 cannot be perfect square. Example 2. Find the square of the following using a property of perfect square. A. 5, B. 9. Solution. A. 5 square is equal to 1 plus 3 plus 5 plus 7 plus 9, which is equal to 25. B. 9 square is equal to 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17, which is equal to 81. Because perfect square of the natural number n is the sum of the first n odd natural numbers. Example 3. Which of the following triplets are Pythagorean? A. In the brackets 3, 4, 5. B. in the brackets 1, 2, 3. Solution A. 5 square is equal to 25, 4 square is equal to 16, 3 square is equal to 9. Because 5 square is equal to 3 square plus 4 square, therefore, in the brackets 3, 4, 5 is a Pythagorean triplet. B. 3 square is equal to 9, 2 square is equal to 4, 1 square is equal to 1. Because 9 is not equal to 1 plus 4. Therefore, in the brackets 1, 2, 3 is not a Pythagorean triplet. Time-saving methods to find squares. Example 1. Find the square of 74. Solution. This is shown as, so 74 square is equal to 5476. Example 2. Find the square of 348. Solution. This is shown as, so 348 square is equal to 1,21,104. Square roots. You know that 25, 36, 49, etc. are perfect squares. You also know that 25 is equal to 5 square, which is equal to 5 into 5. 36 is equal to 6 square, which is equal to 6 into 6. 49 is equal to 7 square, which is equal to 7 into 7. 5 is called the square root of 25. 6 is called the square root of 36 and 7 is called the square root of 49. Thus, square root of a number m is that number which when multiplied by itself gives m as the product. So, if n is the square root of m, then m is called square of n. M is equal to n multiplied by n. The square root of m is denoted by root of m. The symbol means square root of. Thus, square root of 64 is equal to 8. Square root of 36 is equal to 6. Square root of 225 is equal to 15. Square root of 441 is equal to 21. Properties of square root. 1. Square root of a natural number ending in 2, 3, 7 or 8 is never a natural number. As you know that a perfect square never ends in 2, 3, 7 or 8. 2. Square root of an even perfect square is even. As you know, square of an even number is even. 3. Square root of an odd perfect square is odd. As you know that square of an odd number is odd. 4. Square root of a number ending in odd number of zeros can never be a natural number. As you know that a number ending in odd number of zeros can never be a perfect square. 5. Square root of a square number followed by an even number of zeros is a natural number, in which the number of zeros in the end is half the number of zeros in the given number. 6. Negative numbers have no square root in the system of rational numbers. 7. If a number has a square root in natural numbers, then its ones digit must be either 0, 1, 4, 5, 6 or 9. As you know that perfect squares have either 0, 1, 4, 5, 6 or 9 as the ones digit. Square root of a natural number by repeated subtraction. If n is a natural number, then n square is equal to 1 plus 3 plus 5 plus 7 plus so on till plus 2n minus 1. Thus, square root of a perfect square can be found by subtracting successive odd numbers 1, 3, 5, 7, 9, 11 and so on till we get 0. The number of times subtraction is performed to arrive at 0 gives us the square root of the given number. Example: by repeated subtraction of odd numbers starting from 1, find whether the following numbers 36 is perfect square or not. If it is a perfect square, then find its square root. NCERT. 36 minus 1 is 35. 35 minus 3 is 32. 32 minus 5 is 27. 27 minus 7 is 20. 20 minus 9 is 11. 11 minus 11 is 0. After subtracting successive 6 odd number, we obtain 0. So, 36 is a perfect square and square root of 36 is equal to 6. Square roots of perfect squares. Method 1. Method of prime factorization. To find the square root of a perfect square by the prime factorization method, we follow the following steps. Step 1. Write the given number. Step 2. Using division method, resolve the given number into prime factors. Step 3. Make pairs of identical prime factors. Since here we are finding square root of perfect squares, so prime factors will always occur in pairs of the same factor. Step 4. Take one factor out of every pair. Step 5. Find the product of these factors. Step 6. The product gives us the square root of the given number. Example 1. Find the square root of 4096. Solution. Prime factorize 4096. On dividing 4096 by 2, we get 2048. On dividing 2048 by 2, we get 1024. On dividing 1024 by 2, we get 512. On dividing 512 by 2, we get 256. On dividing 256 by 2, we get 128. On dividing 128 by 2, we get 64. On dividing 64 by 2, we get 32. On dividing 32 by 2, we get 16. On dividing 16 by 2, we get 8. On dividing 8 by 2, we get 4. On dividing 4 by 2, we get 2. 4096 is equal to 2 into 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 2. Making pairs of identical factors, we have 4096 is equal to bracket 2 multiplied by 2 into 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 bracket 2 multiplied by 2. Taking one factor out of each pair, we have square root of 4096 is equal to 2 into 2 into 2 into 2 into 2 into 2, which is equal to 64. Thus, square root of 4096 is equal to 64. Example 2. The students of class 8th of a school donated rupees 2401 in all for Prime Minister's National Relief Fund. Each student donated as many rupees as the number of students in the class. Find the number of students in the class. NCERT. Solution. Let the number of students in the class be X. Thus, each student donated rupees X. Therefore, X into X is equal to 2401. Implies X square is equal to 2401. Prime factors of 2401 are: on dividing 2401 by 7, we get 343. On dividing 343 by 7, we get 49. On dividing 49 by 7, we get 7. On dividing 7 by 7, we get 1. 2401 is equal to 7 into 7 into 7 into 7. Therefore, square root 2401 is equal to under root 7 into 7 into 7 into 7, which is equal to 7 into 7 is equal to 49. There are 49 students in the class. Square roots of perfect squares. Method 2. Long division method. We have already learnt the method of finding the square root of a perfect square by prime factorization method. But if the number is very large, then the process becomes lengthy and cumbersome. In such cases, we use the method of long division. In this method, we follow the following steps given in examples. Example 1. Find the square root of the following numbers by long division method. A. 5,31,441. B. 44,01,604. NCERT. Solution. A. 5,31,441. This is shown as Step 1. Write the given number as the dividend, that is 5,31,441. Step 2. Make pairs of the digits starting from the right. Step 3. Select a dividend whose square is equal to first pair, that is 53 from the left if not possible. Then the number whose square is less but closest to the first pair from the left and subtract this square. Step 4. Bring the next pair down and write it on the right of the remainder and we get 414 as the new dividend. Step 5. Double the quotient 7 and we get 14. Make a 3-digit number by choosing 2 when 142 is multiplied by 2. Product is less than 414. We write 2 in the quotient as well. Step 6. Subtract 284 from 414 and we get 130 as the remainder. Bring down the next pair and write on the right of 130. Add 2 to the divisor and repeat the step number 5. The quotient 729 is the square root of the given number. B. 44,01,604. This is shown as Step 1. When we pair digits starting from the right hand side, we are left with one digit, that is 4. So we think of a number whose square is less than or equal to 4. Step 2. This step needs special attention. Now the new dividend is 40 and we can't place 1 with 4. Because 41 into 1 is equal to 41, which is greater than 40. So, we place 0 in the divisor as well the quotient and proceed further as in the previous example. So, square root of 44,01,604 is equal to 2098. Example 2. Find the greatest number of 3-digit, which is perfect square. Solution. We all know that the greatest number of 3-digit is 999. But 999 is not a perfect square. So we must find the smallest number which must be subtracted from 999 to make it a perfect square. This is shown as This shows that if we subtract 38 from 999, the resulting number will be a perfect square. Thus, 999 minus 38 is equal to 961 is the greatest number of 3 digits, which is a perfect square. Example 3. A gardener has 1000 plants. He wants to plant these in such a way that the number of rows and the number of columns remains same. Find the minimum number of plants. He needs more for this. NCERT. Solution. Number of plants gardener has is 1000. Let the number of rows is equal to number of columns be x. This implies Total number of plants is equal to x into x, which is equal to 1000. X square is equal to 1000. X is equal to square root of 1000. This is shown as, this implies 1000 is not a perfect square number. 31 plus 1 whole square is equal to 32 square, which is equal to 1024. We can see that 31 square is lesser than 1000, but 32 square is greater than 1000. So, 1024 minus 1000 is equal to 24 plants. He needs more. Thus, the required number is 24. Square roots of numbers in decimal form. Method. As we all know that the square root of a number is that number which, when multiplied by itself, gives the same number. If a square is equal to b, this implies that a square is equal to under root b into under root b, or a is equal to under root b. Because 0.3 whole square is equal to 0.09, this implies that 0.3 is equal to under root 0.09, or under root 0.09, two places of decimal, is equal to 0.3 in square root 1 place of decimal. 0.22 whole square is equal to 0.0484. This implies that under root 0.0484, 4 places of decimal, or 0.22, 2 places of decimal. 1.4 whole square is equal to 1.96. This implies that under root 1.96, 2 places of decimal, which is equal to 1.4, 1 place of decimal. Example 1. Find the square root of the following decimals. A. 1043.29. B. 445.21. Solution. A. Under root 1043.29. This is shown as, therefore, under root 1043.29 is equal to 32.3. Step 1. Make pairs of digits starting in the direction of arrows. Step 2. Proceed as in the case of the square root of a perfect square. Step 3. Integral part is finished. Place decimal in the square root and bring down the decimal part. B. Under root 445.21. This is shown as, therefore, square root of 445.21 is equal to 21.1. Square root of fractions. We have learned the method to find square root of perfect squares of whole numbers and decimal fractions. Now let us expand it to find the square root of the numbers which can be rewritten as perfect squares of rational numbers. 16 by 25 is equal to 4 square by 5 square, which is equal to 4 by 5 whole square. This implies square root of 16 by 25 is equal to 4 by 5. 64 by 81 is equal to 8 square by 9 square, which is equal to 8 by 9 whole square. This implies square root of 64 by 81 is equal to 8 by 9. In rational numbers, a by b is the square root of c by d if a by b whole square is equal to c by d. This means that square root of a rational number is that rational number which, when multiplied by itself, gives the given number. Example. Find the square roots of a. 4 by 9, b. 3811 upon 25. Solution. A. Square root of 4 by 9 is equal to square root 4 by square root 9, which is equal to 2 by 3. B. Square root of 3811 upon 25 is equal to square root of 961 by 25, because 3811 upon 25 is equal to 950 plus 11 by 25, which is equal to 961 by 25, which is equal to square root of 31 into 31 by 5 into 5, which is equal to 31 by 5, which is equal to 6 1 upon 5. Note, in this chapter, we are concerned with only positive square root of a given number.